Our next problem, we are trying to basically derive an integral. That's the best way I can say it. So basically what I've always told you guys is that deal with the inside first. So we're gonna deal with this big thing here first. Okay, it makes our life much more easier, because we'll find the answer and just plug it in there, and then we'll be able to find the derivative of that relatively easy compared to the task we have right now. So let's do that first. So I've written down the integral and my problem down here. So let's do this. Okay, so first things first, right? Do you know of anything that will give us tan? So like the derivative of a particular, trig function, that'll give us tan. I mean, let's look. I mean, we've got sine will give us sine of x, for instance, will give us cosine of x. The derivative will give us cosine of x, right? Cosine of x, the derivative will be negative sine of x. I mean, the derivative of tangent x is secant squared x. Secant x, the derivative of that is going to be secant x tan x. So there's really none of them that will just give us tan of x or tan of t, so we're gonna have to get a little smart to try and solve this problem. Okay, first things first, I'm gonna make my life easier by taking out the 2, because I'm allowed to, and I'll have 2 goes to 3 of tan of t dt. Okay, so let me see, what can I do? I'm gonna just use some trig identities and trig reciprocals to try and break down this tan. Okay, so I've got still the 2 out there, from 2 to 3x, and basically I'm gonna write it as sine of t over cosine of t dt. Now many people may ask me, why am I writing it this way? It's because what I'm trying to do is break it down so that I'll be able to use u substitution. So you can see that sine of t over cosine of t is the same thing as tan t, which is just written in a different way. So let's get a little smart over here. Okay, I've got a 2 and a 3x over here. What I'm going to do is I'm going to bring up the cosine, right? But because I'm bringing it up from the bottom, or from the denominator, it's going to have that negative 1 there. Again, this is the simple rules of exponents. If you take something up from the denominator, then it becomes it basically becomes, how can you say it? The exponent becomes a negative, or vice versa. So now let me use u substitution. Okay, so let's look at this. Let's say by u, I'm going to put it as cosine of t, right? That means my du is going to be negative sine of t. So you can already start seeing that we've got something here. The only difference is that we don't have a negative in here. So what we're allowed to do, right, is we can place a negative, like we can multiply here everything there by negative 1, but we'll have to also multiply the outside by negative 1, the reciprocal basically. So then the reciprocal of negative 1 is negative 1 over 1, but that's still negative 1. Okay, so what we're gonna have over here is we're gonna have negative 2 times the integral of 2 to 3x negative sine of t cosine of t to the negative 1 dt. Oh, by the way, this is dt, because I forgot to put that there. Okay, so now you can see that we've got our u as cosine of t and our du as sine of t. Okay, so what we can do now is we can replace them. So I'm going from 2 to 3x. So this is gonna be my du basically, and u to the negative 1. Okay, now if you remember anything, right, if you remember logarithms or the exponent or the integral of logarithms, it's the fact that if you ever have something like the integral of 1 over x, right, dx, that's actually just going to be ln of x. Okay, I hope you, if you don't remember that, go back and check over your logarithmic integrals, or integration of logarithmic functions, should I say. So in this instance over here, u to the -1 is the same thing as 1 over u. Okay, so this is a logarithm basically. So what I'm going to do is I'm taking the integral of it, so I'll have -2 ln of u, right? And this is going to be from 2 to 3x, okay? But basically, because I'm using u substitution, I have to go back and get my u. So my u was cosine of t, right? So that's what I'm going to do here. Just going to replace my u with cosine of t. And now I'm back to simple integration, okay? So what I'm going to do now is I'm just going to plug in my numbers for wherever I see a t. I'm going to put a 3x, then minus, and again this is going to be minus, maybe I should put this also in brackets just to show you what's happening, minus -2 ln of cosine of 2, okay? So what's going to happen? We're going to have it as -2 ln cosine of 3x plus 2 ln of cosine of 2. Okay, now this may look a little complicated, but basically we found the integral, right? So in place of this this whole big shabam here, I don't know what to call it, but in place of this whole big thing here, we're going to put in our answer, okay, and then find the derivative of that. Okay, so let's do that at the bottom here. So it's simply going to be dy dx of -2 ln of cosine of 3x plus 2 ln cosine of 2. Okay, so I mean, we could write this as f of x, if you're uncomfortable with the notation of dy. So if you want to write this, I'll write it as I'll change it to f of x, because that's what most people are comfortable with. So f of x is equal to -2 ln cosine of 3x plus 2 ln cosine of 2. Okay, so I'm going to just now find the derivative of this. Okay, so -2 is going to remain outside. Now remember, the derivative of a cos of ln is basically, you're going to find the derivative of the value, whatever value it is, and that's its value, should I say, and that's its value anyway. And you're going to find the derivative of this inside here. So what's the derivative of this? That's going to be -3 sine of 3x, right? And you're just going to be putting it over just going to put it over whatever you already have. So whatever you already had, should I say. So that's just going to be cosine of 3x, okay? And this, okay, the derivative of cosine of 0, that's basically just the derivative of this whole thing is basically just going to be 0, because it's a constant. Can you see we don't have any x's in there? So yeah, that's just going to become a 0, okay? So what's going to happen is we're going to have negative, oh, I guess we don't have negative anymore because they're multiplying each other. We're going to have 6 sine of 3x over cosine of 3x. Now sine of 3x over cosine of 3x is the same thing as 10. So it's just going to be 6 tan of x. And this would be our final answer. Okay, thank you for watching.